Hello everyone, welcome to Statistical Foundation for Big Data Analysis. I am Arindam Banerjee from Department of Mathematics at IIT Kharagpur. This is a course on statistics that is essential for analyzing big data. Now, this term big data, statistics is essential for any kind of data analysis. That's the grammar of data analysis, science of data analysis. And this term big data became very popular in last few decades or slightly more. This actually denotes a very specific kind of data, and the arrival of big data to our research scenario became possible due to the communication revolution and the exponential growth of internet, as well as the exponential growth of computing power, the human computing power. The computing power the computers nowadays have were unimaginable 30 years back. The arrival of big data, the creation of big data happened due to these two factors. Now, big data, handling of big data involves, very crudely speaking, it's much more complex than the crude beginning picture I am giving, two aspects, one engineering, one statistical. The statistical side deals with analyzing big data. The complexity of that comes from so generally speaking, data has various features. So, for example, if you are interested in blood sugar of a person and you think that body weight and height combination has something to do with blood sugar, so then you have three parameters: blood sugar, body weight, height. Maybe age is also a factor, so that will make it four variables. So big data will have, this data will have four features: body weight, height, age and blood sugar. Maybe there is some interrelation between that. You will collect data and try to analyze this relation. So maybe blood sugar is a function of height, weight and age. Now, when you are thinking about big data simply as data, generally what happens that there are way too many features, like millions probably of features. There are further complexities that may remain. So there may this simply writing numbers in a vector form or simply having one number for each feature may not just be sufficient to analyze the data. There may be some other structures, and the list goes on. There are various aspects, not just many number of features, but various aspects like structures, availability, the size of the data, the sheer size. I mean, like, we are equipped to, maybe your local computational system is equipped to deal with 1 lakh data of, let's say, 50 feature. The big data when you are handling, you may be dealing with 10 crore data with 50,000 features. Just to give you an idea. This already gives you the complexity of the situation. And then of course I was saying there may be certain relation, there may be some interdependence on the features which we'll see in terms of graph data very soon. There may be certain extra mathematical structure than just bunch of numbers. So these aspects and many other aspects like this are handled in the statistics side of the big data, and that the statistics that is required to handle such things is the main focus of this course. But there is another hugely important, perhaps even much more important aspect of big data, which we will not get into this course, is the engineering aspect of the data. The collection and storage of the data and maintenance, management, simply giving people access to it. Now, imagine, I mean, like in some computer hard disk, if you are trying to store data, I mean, like if you are trying to, let's say, store data of, in some class students have taken midterm and you have just, want to store the results, you just put it in an Excel file or CVS file or whatever. So you just put them as a column. Let's say you will have just two columns, the roll number and the marks. If you want to see score of a particular person, you just scan the roll numbers in order and you just go to a particular position and see it. This simple task is not so easy for big data. There are millions. If you just want to put it in column form, it's probably will be impossible. So you have to come up with a very shared storage thing. You will store certain part here, certain part here, certain part there, and so on. And then it will be such a very complex network, and then accessing, like if somebody wants to access a certain part of the data, becomes extremely important. That's just one part of it. Simply collecting such a huge number becomes a massive challenge. So for example, satellites, this is one problem faced by space agencies all the time. Satellites are continuously collecting data. So they are, in space there are continuously many frequencies, many signals are coming, and the satellites are basically collecting them real time. It's coming all the time. If it actually tries to store, let's say, first of all, if the data is coming in real time, of course storage will always, you are grabbing data, putting somewhere. If the flow of data becomes like a flow of river water, like a actual real time, continuously slowly flowing, the computing systems are discrete by definition. The storage is supposed to be lagging behind the storage process, and forget about analysis, storage itself, collecting and storage is supposed to lag behind the flow. So this is a problems faced by all space agencies, like they continuously are getting signals, they just don't know how to even, forget about analyzing. If you're, people think that getting more data is really nice because you can analyze, you keep hearing words like data is the new oil, etc. But storing them is a huge challenge, because whenever they are coming in a continuous time, and to make it worse, in space what happens, sometimes this data is junk. So amongst this huge amount of data, there may be a huge portion which is just useless or junk. There may be repetition. So, but then if it is coming continuously, how do you process continuously? How do you detect things continuously? The portion you have to junk continuously. All these challenges keep coming when you are handling with big data. So in this first lecture, we'll just basically randomly chat about big data. In second lecture onward, maybe first 3 lecture we'll talk about generalities. Fourth lecture onward, it will appear like a classical statistics course for some time before we get into the, let's say, slightly more non-trivial aspects that are generally not covered in a standard statistics course. But as we were saying that statistics is foundation for data analysis. So even before we can give you a glimpse of some of the new feature, some of the advanced feature of statistics which are, let's say, specifically important for big data. After all, big data is data. So to cover the foundation for some time, we have to do classical statistics, which we'll do, let's say, 4th lecture onward, 4th, 5th lecture onward. But first 3 lectures, I would try to give you a general overview. So the first class will be on big data itself, like what's the definition of big data, where they are, which are the scenarios where they appear. So then in second lecture, I'll just sort of give you the overview of the type of mathematical formulation data, mathematical shape data text, and third lecture will get into this overview of statistical process, and then from 4th lecture onward, it will actually start doing more concrete analysis. So let's get into first the notion of big data. This term became very popular in last 15 years or so. It became available in last 30 years or so. This became in the public domain. It started becoming popular in the public domain in last 30 years. Became very popular in last 15 years or so. So what makes a data big data? What's the definition? What are the features of a data that makes it a big data is something we'll start with. Then we'll get into some examples of big data, and then we'll discuss some of the challenges with handling big data. So generally speaking, data sets are too large or too complex to be dealt with traditional data processing algorithms. Big data are too large or too complicated to be handled by traditional data processing algorithms and softwares. These data sets are continuously growing. So exponential growth in computing power enabled, I mean, after all, data, data is something there, there is something outside. From when you say something, the word data, what comes in your mind? You're trying to understand something, some phenomenon. You're kind of doing some experiment and collecting the results. That's your data. The thing is, so exponential growth in computing power actually created new phenomenon. Social media is a new phenomenon. YouTube, for example, YouTube videos are not just YouTube videos. First of all, video itself is a complex thing because you have pictures, you have you have pictures, you have music, that is the audio, you have dialogues, and then in YouTube video you have users that are commenting them. Now, if you consider a YouTube video as just one data, if you want to consider it as a data, like classically people think of data as just bunch of numbers, that totality of bunch of so it's a vector value, it's a tuple of numbers. That's what you think, like for example height, body weight, blood pressure and age, let's say. But here, what are the replacements of those things in this context? It's a far more complicated scenario. There is a video, let's say certain user who is posting that video, certain users are commenting on that video, and then the user who is posting this video, he is posting other videos. The same user who is posting this video are commenting on other videos, watching other videos. The people who are commenting on these videos, they are commenting on some other videos, watching some other videos and not commenting on that. And then for all these users, some videos are coming in their feed who are simply not watching. So if you want to understand the Facebook phenomenon, you really need to collect data on all these things. So how do you even view, how do you even abstract that out into a mathematical format before you can analyze? So this is a completely new phenomenon that happened simply because exponential growth of computing facility. After all, growth of computing facility allowed you to do so many things using internet. And secondly and thirdly, of course, it gets constantly generated. There are literally constantly videos are coming in Facebook. I mean, if you take the number of Facebook or YouTube, all in social media, these are constantly coming. These videos are coming constantly. And also, frankly, the satellite data we are showing, that's also another example where constantly signals are coming. So all these features, all these three things are common features of big data. It's huge and complex. Let's say you can somehow do the processing and somehow turn it into a mathematical object. Let's say even somehow by some magic we'll see in next class, you can convert everything into a vector form, like a long tuple of numbers with many features, like let's say a huge tuple, like with various columns, like if you see a tuple as let's say 2,3 is a tuple or 2,5 is a tuple, and so this is a tuple. So this is a tuple, or -5 -4 pi e3 is a tuple. So let's say by magic, so generally data, if you have seen, data comes like this. So this is E11, E12. Data generally tends to come in a matrix form. This is one data point. This is another data point. So this is traditionally, this is how data comes. This is a data set of size m with n features. let's say by magic, this YouTube data that you want to analyze is converted into some huge, so a YouTube data has been converted into a huge data set with B. So I am putting big N to indicate this is very, very big, and let us say, let me put a big here also, far down, B M N. So the thing is, if you end up somehow converting into classical type data sets, still this N being very big and M being very big will make data processing algorithm and softwares very classical softwares and algorithms very incompetent to do that. Now first, even at the analysis level, let us say, so some, by the way, some familiarity with probability theory and linear algebra will really help, because we are trying to give a quick overview of some of the statistics. Frankly speaking, the topics we will cover in statistics in this course, you know, statistical inference, some multivariate data analysis, some statistical learning theory, all these generally require a full course to do it in full detail. So we will just give you glimpse of it. To truly appreciate them, you will need to take some advanced full courses on that, but before that, all these need some exposure to linear algebra and probability theory, that solving linear equation, inverting a matrix, determinant, and in probability, some exposure to probability distribution, random variable, expected value, etc. Independence, conditional independence will be really helpful. Otherwise, you will have to pick those things up simultaneously on your own. Now, suppose in linear algebra is extremely important in statistics. I mean, you know, you can see already this is in a matrix form. This is a good way to put it in matrix format. Matrix of this is M cross N matrix. So analysis of this data generally involves matrix algebra of Gaussian elimination and matrix inversion, etc. But the point is, because N is very big and M is very big, even this matrix analysis can become cumbersome. And matrix calculations can generally be done, some of it, at least some important parts of it, can be done in polynomial time complexity. Even that becomes very complicated. Those calculations can become complicated. We need to look for some high performance computing techniques to even simplify that. So even analysis becomes difficult, and also the softwares, like the softwares which can handle certain amount of data, the massive size of these data will make these softwares also kind of not so efficient, the traditional softwares, to handle these data. I mean, like, you know, handling big data requires specialized software platforms. So some of the characteristic is volume. They are huge in size, generally larger than terabytes and petabytes, where 1 terabyte is 1024 gigabyte and 1 petabyte is this number 1048,576 gigabyte. They are huge in size, immense in scale, exponentially growing, the YouTube example shows. Variety of sources. So the big data, for example, if you look at Facebook, that's just to give you an example, one can post video, one can post comment, one can post link. It can come from variety of sources. If you look at the meteorological data, I mean, you can, if you see the data collected by various space agencies, it can be magnetic resonance, it can be various other signals, it can be some objects in space, it can actually be other satellites, it can be coming from various planets, various other heavenly bodies, and it can come from, it can be picture, it can be sound, so it can be from various sources. So you need specialized tool to deal with them. So variety, so for example, it comes in various formats. Earlier data used to be, earlier when you had to handle it was just tables, then it came in form of some database, then data became photos, web data and audio. Now it's actually social media data which can combine all the above, and more. So big data is basically these two already, volume and variety. So whenever you will see characteristic of big data, these V's keep coming and these V's keep increasing, but volume and variety, and you will see velocity. These are the oldest three V's. I will come to the velocity. So it's coming from variety of sources and variety of formats, and it's of massive volumes. So the variety makes it, variety is also one simple mathematical way of viewing variety. Will see this can be structured data, semi-structured data like XML or JSON files, and it can be simply unstructured like social media posts, audios, videos. So these are the sources of varieties because it's coming from these so many different sources. Automatically it's of various different kind, and also, as I said, social media data are complex, too complex. This complexity also creates variety. The complexity of the phenomenon forces the data that you will collect from them to be very complex, to be representative. Data analysis, from data analysis perspective, when you want to understand something based on the data has to be relevant. Data has to be representative of that phenomenon. So the phenomenon itself is very complex, then the data has to be very complex. The point is, this computational power allowed us, one, to actually study very complex phenomenon like what's happening in space, and also created new complex phenomena like social media. So this is the milieu from where big data came up. So another of the old V's in big data characteristic is velocity. It comes now, it's literally coming real life. It's getting generated almost real life, real time, not real life, real time. So earlier data used to come in batches, just one batch. Then there was a time when they are coming periodically, then it slowly started becoming real time, and now it's literally getting generated instantly. So key aspects of big data velocity is the real time processing and constant flow. And another thing is, sometimes it's important to act. So if you're a satellite company, let's say, who is trying to predict GPS, so if there is a roadblock, sudden roadblock, you have to act. You cannot say you will not act. So big data, they are important data. So literally, if you're collecting data in a giant clumsy city, traffic wise clumsy city, important city, some capital of a country, you have to act. I mean, so many people are driving. If you're satellite enabling GPS, you have to continuously update the road situation, and the situation changes literally real time. So the importance of action is another feature of big data. Also e-commerce, so the Amazon and all other Blinkit or Zomato, all these platforms are also, the data that they are dealing with are massive and complex in size, and they are also getting generated constantly. I mean, like for example, Zomato certain restaurants are out of a particular dish. Let's say a person is sending order, between the person has selected and like press the GPay button, and the bank finishes the processing the money, the order may run out. So and these softwares have to take care of that. Another thing, is important feature, finally the data has to be of good quality. So it has to be of proper quality, and so with the advancement of our data processing and computational skills, now we are in a position that we can ensure certain degree of accuracy now. Of course, for small data, but for big data also. Big data, generally speaking, is not junk data. We can ensure that ultimately the thing has good quality data. So it's important for the data, the ready processed data, to be of high quality, because data quality is of course important for better decision making, risk mitigation, and involved operation, and getting relevant insight. So quality of data is something, again, some important aspect of it. So some examples, I mean already we are talking about some example. These social media, the streaming platforms generates big data. The data coming from that is pretty complicated and fits perfectly in this big data mode. The type of data is generally video and text, and also interlinks between them. Same for social media. That's actually network data. Frankly, from one can consider the streaming platforms also a type of social media. There also you will get network data. By network data we mean for various aspects, various profiles, how they are interconnected. So supply chain optimization is another context where big data is quite important. So there basically generally in modern life the supply chain is very complicated, and big data, so if you collect if you keep constantly collecting data and you preserve the database for certain supply chain, certain logistical chain, that becomes very useful. The analysis of that can give you future insight. Even policy making, global policy making, securing your own country's supply chain has become one of the biggest priorities for countries nowadays. Internet cyber security is another area where big data is quite relevant for threat management and monitor system vulnerability. Agriculture is another area where big data is quite important, has become, you're collecting sensor drones and satellite images of crop health, soil condition and moisture to optimize irrigation and fertilization. Here mostly the image data is that people process. Weather forecasting is another area where big data processing and big data analysis has made lots of progress. I mean, nowadays we can fairly accurately predict weather. I mean, you see some of the websites, I mean Google itself, I mean in various places they predict weather of every hour, and they more or less, let's say one can say the prediction of weather is much better than what it used to be earlier, simply because we can process data of many features. We can combine data of many sources and process them together to come up with a better model. So here some artificial intelligence and machine learning techniques are used to find complex weather forecasting models. Transportation I have just mentioned. So GPS data, that's actually is another example of big data. Cyber security also is another place. We were talking about threat management, is another area, another domain. Retail and e-commerce, Amazon's recommendation engine continuously analyzes user behavior, user searches and user purchases, and like purchases by, let's say, users of similar behavioral pattern. Genomic research is another area where big data has become very big. Human Genome Project is a huge source of data generation, and potentially personalized medication, the discovery of certain personalized medication based on this data can be achieved in future. So online educational platforms also, they are also a specialized kind of that, just like social media. Also this is another place where various people are logging in and trying to learn certain things. So analyzing user behavior, they can tailor-made individual learning process. Health data, another huge thing. Potentially if hospitals keep record of all patients that are coming there and doing all the tests, that will generate a huge data, and that can enable health policies of countries in future. Census data, of course, it not just counting the numbers, it also collects various features for each person. For huge country like India, this will potentially turn into big data. Fraud detection, another area where online transactions are monitored by banks and various other aspects of various behaviors of users in past together, combining together to enable automated fraud detection is another area where big data science will be useful. We discussed about environmental data. Meteorological data is important for weather prediction. availability of drinking water in various regions, early warning for some hurricane or tsunami. I mean, nowadays we are fairly good at predicting some of these, tragedies. Not always, but sometimes. So, of course, big data comes with various problems. Volume related problem we are mentioning, the storage and management becomes a huge problem. Sometimes what happens, that creates performance bottlenecks. Constantly data is coming, it's just the system is overwhelmed. It cannot, it is stuck at something, processing something, and much more has already come, so it cannot analyze that. Cloud computing, data compression, etc. are potential solutions, and research is of course ongoing. Data quality related issues, we are talking about this data collected by satellites, like a huge amount of data there is junk, and that has to be processed. And finally, the outcome, like once you get rid of the junk, what is left is also big data. Let's say it's like huge, immense amount, and you are taking 50% of that, that still remains immense. So, automated duplicate detection, like whether same data is getting duplicated, that's one area people are focusing on the research. That helps quite a lot, and some real-time data monitoring tools are needed for these kind of things. So newer system, that's I was saying that the computation fundamentally, processing and computation by computing system is fundamentally a discrete thing. So how they scale themselves, because after all you have to storage, you have to predict how much data will come in future, and often what happens that whatever you have predicted, whatever the amount is coming much more, or that amount is not coming, somehow data flow has stopped. So storage management is an issue. So distributed computing, virtualized data platform is something that's our work is being done there to potentially handle this. So there are data breach related challenges, management challenges, because it's a complex issue, complex problem. So obviously there will be management problem, because you have to store data on various different systems. It creates another network structure, and of course if it is different system, more systems are available, security becomes an issue. Complexity of data integration, we are talking about weather prediction. Weather prediction is becoming more accurate, because data from various sources are being integrated together. Oceanic data, meteorological data, etc. is being combined together to predict weather. Satellite data, oceanic data, etc. This data integration, data from various sources together combining, and totality of a particular data for a particular analysis, this integration becomes very complicated for big data. Cost management issues, I was saying, like provisioning certain space and suddenly you see that it's not useful, or let's say you overestimate the cost or you underestimate the cost. That is something quite happens quite frequently. I just end this talk with these quick overview. You can, to get an idea about big data, you can read several online sources like Wikipedia, etc. There are some nice books also on these issues about big data. I'll try to put some of them in the reference of this course. See you in second class. Thank you.